Excellent. Well, today's lecture, I want to continue what we've already started in terms of covering arrays. So last lecture, we had talked about multidimensional arrays, and we had talked about the distinction between passing by reference versus passing by value. So today, I want to go back to our dice game. We've already used the dice game previously. Let's see, what did we implement in our dice game last time? Let's see here. So, I think what we had done really for our dice game was to go ahead and look at how we can evaluate. It wasn't the last lecture we did, but we can go back to it here. So the last time we touched the dice game, we had, let's open it up, and actually, why don't we actually copy this? We'll bring it into the current workspace. So, okay, perfect. So last time with the dice game, what we had done here was we hadn't changed anything per se about the dice class, but what we did change was the dice tester class here. So remember, the mechanism we did before had looked like this, right? Where we had to define a set of variables for each face, and then we improved this with our D6 tester class when we first talked about the power of arrays. We could go ahead and use an array to hold those frequencies, and then we could test any arbitrary number of die together, 1, 2, 3, 4, 5, 6. And this really empowered our ability to test our dice class. Well, now I want to get into a concept where we're actually going to our dice class and make it even slightly better. And so what's going to allow us to make it better is going to be this concept that's called variable length arguments. Oh, we're getting an echo of sorts. Let's see. I don't know where it could be coming from. Make sure that. Oh, I have an idea. Give me a moment. Okay, something like that. Like that. Yeah. Well. Okay, is that better with the echo? Excellent. There's the chat here. There we go. Okay. One last thing. Let me go here. Okay. Okay, so what I want to look into is this concept of a variable length argument. So up to this point, we've seen that we can pass an array into a method as input. And when we do that, we're giving a reference of that array to the method. So any kind of processing that happens in there, whatever reading or especially writing, will change the state of our array for everything else that has a value of that. Let me show you something that's a little bit interesting, though, in terms of the variable length arguments. We're going to do this two ways. I'm going to kind of reserve explaining what a variable length argument is until we can actually see it. And once we actually see it, I'll go ahead and give you a more kind of formal definition. But let's talk about what we're going to use variable length arguments for in today's lecture. So remember, we have this dice class where the intent here is we want to improve our dice utility class with the following problem statement. Suppose that we want to add a method that allows us to roll an any-sided die. So up to this point, we're limited to D6 die, right? So how might we implement that based off of how we know the D6 die already works? let's see, we'd probably do it something along the lines like this. We'd have a public static method, right? It's a property of the class itself. It's going to return back an integer value, which is going to represent the value of the die after we've rolled it. So the side that is up, we need to give it a name. Since this is going to be an any-sided die, we can just call it roll dice or roll, or we could call it roll DN if we wanted to, but we'll call it dice. And then we'll pass in an integer value that represents the face count on it. So if it's a 6-sided die, it would have 6 faces. If it's an 8-sided die, it would have 8 faces. If it was a 20-sided die, it would have 20 faces. Then what I would do is the same thing I have been doing. I'll go ahead and use the math utility class to produce a random number between 0 to 1. I'll multiply by that scalar value that'll give me up to whatever the face count is. I will then cast that into a integer and then add 1 to it. So I offset from 0 to whatever n minus 1, so that's 1 to n. And then I would return that. So this should give us what we're looking for in terms of that behavior. Why don't we go in and add that into our dice class? And actually, let's go grab. Okay, so let's also grab a tester here too. So let me go here. Do we have? Let's just do this. Touch dice. So we'll make a new dice tester. Let's do this. Public class die tester. Public static void main. Inside of there, we'll have our string array that contains arguments. And here we're going to test this out. Let's do dice dot, and what do we call that method? We called it roll dice. Okay, so suppose we wanted the behavior of a 6-sided die. Then that's what we would expect. We'd put 6 faces. Let's get our roll value here, and let's just do a system.out. System.out.print. Oops. Actually, let's do printf, and let's put that the roll. Let's do this. Faces is equal to 6. Let's pass that as a variable so that I can have faces for and sides. Okay. Is okay, perfect. So the number of sides and then what we rolled. And then that will also be a integer. So then we will put the number of sides here, and then we will have our actual roll. Okay, let's test this out. Let's see if this doesn't produce what we think it should. Let's blow that up some. Let's compile our code. Okay, what does it? No, let me make sure I saved it. Okay, what does, oh, dice. Problem with copy pasta here is we left off a curly brace. So brace to brace, perfect. Open, close. And that compiles just fine. Okay, so now let's run our dice tester and see what we get. Okay, so on a 6-sided die, we rolled a 1, a 4, a 5, a 5, a 3, a 5. Perfect. That looks exactly what I expect. Now let's change this. Suppose we put 12 here. Okay, and so on an n-sided die 12, we can roll a 6, a 10, a 10, a 5, a 2, an 8, 7. That looks good to me. Let's put a 2 here. Suppose we had a two-sided die. Actually, let's just do this. So actually, you can actually run. I don't know if I've showed you this trick. As long as you have your main method, it's actually possible to run code and compile it in the same action. So I can actually run Java and then die tester.java, and if there's any changes, it'll try to compile and run that simultaneously. Okay, let's see here. So between 1 and 2, that's exactly what we'd expect. We can even have die here that are impossibly shaped, like a 13-sided die. Anyway, we can see that this all works. Yeah, let's see. Save. Okay, so we have 13-sided die. Okay, perfect. So,
I have a question.
Yeah.
For that code, it's possible to get a 0.
No, and the reason why we can't get a 0 is if we go back to our die, we have this offset of 1. So if we were to generate a 0, so recall math.random can generate any number between 0 to 1, but not including 1, so like 0.99999, and then whenever you run out of memory for that, then we multiply by whatever our face value is. So let's say it's just 2. So in that instance, it's either going to be 0 or it's going to be a 1 after we truncate it. So be up to a 0 multiplied by 2, it could be 1.999999. But then we truncate it, so it's going to be either between 0 or 1, but then we're going to offset it by 1. We're going to shift all of the values to the right. So our 0 becomes our 1 and our 1 becomes our 2. And there's instances actually where sometimes you might want to shift to the left as well. So one cool thing you could potentially do, I don't know if anyone had done this for their zombie game, but you can create a random value that scopes between -1, 0, and 1, right? So if you take and generate 3 random values, so let's say it's 0, 1, and 2, and if you subtract it by 1, your entire range shifts to the left on the number line by 1. So you go from 0, 1, 2 to -1, 0, 1. And then imagine if you use that as your random move for your zombie. So then your zombie, each turn, would randomly go in the X direction, -1, +1, or 0. It just stays still on that axis. And so that's an alternate way we can create a randomized zombie movement. So I just want to highlight that when we shift the number of values, when we shift our randomized values, we don't always want to shift them to the right. We shift them to a right in this instance because that emulates what happens on a die. But sometimes for the problem at hand, we might want to shift everything to the left because maybe we want to have a mix of negative numbers and positive numbers that are part of our stochastic process. So always keep that in mind when you're modeling something that involves randomness. It's like, what is the range of my values? What is the starting, the maximal and minimal? What is the distribution of those values? Like, is it Gaussian? Is it uniform? And does it include just positive numbers, or does it include a collaboration or a combination of positive and negative numbers? Excellent. Does that answer your question? Okay, so we have a die now that can, we have a method now that can roll an any-sided die. And here, I like the name roll dn better. So I'm going to call that dn here. So the next thing we might want to do to improve our die class further is suppose now we want to add a method that allows us to roll multiple n-sided die. So here, what we already had was we have the roll d6, and then we had an overloaded method that rolls multiple d6. Here I have a roll dn. Suppose I wanted to go ahead and roll multiple dn. How might I do that? I can't simply just do a quantity because the thing that gets passed in is the number of faces. So I might do it in the way that we learned how to already pass arrays, right? So as opposed to a number of die we need to roll, maybe we'll have a collection of face counts that represent the first die, the second die, the third die, the fourth die, and what have you. So suppose that this is the solution we go for. So we have an array of integers that will hold each face count for the multiple die we want to roll. And then suppose that we have our die sum. Then we do this enhanced for loop for each die count, for each face count, for each n side. Let's call this n side inside of the dice array, or keep it die. We will roll that die, get the value, and then we will add it to our sum and return our sum. So here, let's put that in there. Let's overload this so it's the same thing. So now I have a roll dn for a singular n-sided die, and then I have a roll dn where I can pass in a dice array. Let's see what that looks like really quick. Let's close that, close that. Let's jump over here. So instead of calling this, let's call this dn. So here, let's create an integer array. We'll call this our die list or die array. And we'll just use an initializer list. So suppose that we have like a 6-sided die, an 8-sided die, a 10-sided die, and a 12-sided die. So suppose that's what we want. Now, because we've created this array as a parameter, we can pass an array into here. And let's test this out. Oh, we're going to have an issue here. We will not have the sides. So let's get rid of that. So let's just have our roll. And actually, why don't we go in here and just to test this out for the purposes of testing it out, let's also do a system.out for console login so we can actually see this in action. So we're going to go and do a quick print f. So we'll put n sides here, %d, and then we will put our roll is %d, and then we'll do a new line character. Perfect. And then we'll put our whatever this die is here, but also whatever the die value is. Okay, that way we can actually examine this as we run this. Let's go ahead, clear this. Let's clear that. Let's compile our code. Let's run our code. Nope. Okay, so here we can see we indeed, during this part of the step, we put this console, this system.out, so we can see on our system what's happening. So notice inside of our array, it rolls a 6-sided die, it rolls an 8-sided die, it rolls a 10-sided die, it rolls a 12-sided die. If I go to my die tester, that's the collection of die I have. It takes all these, it sums it up, and it returns back to my die tester the value of 20. So this works, right? This allows me now to have my dice utility class have the ability to roll any number of n-sided die, but what's the deficiency with this? What makes this a little bit more difficult? Any guesses? Like, for this works, but do you think there's a better approach? Is there an approach that you'd prefer to see? Or do you think this is just a fine approach?
Maybe a way to prevent two guys from on the same number.
Well, unfortunately, because it's a stochastic process, that's something that can actually happen in nature. But what's something a developer needs to know in order to use our roll DN method that's a little bit more complicated than our other roll D6 method? So what was our roll D6 method? Do you remember our roll D6 method? We had this one that doesn't use a parameter, this one that used a singular parameter where we can just pass in a value in there, right? What about this new method? What does this new method require in order for us to do multiple n-sided die? What do we have to supply that method? An array, exactly. So we're having to construct an array for the entire purpose of just sending into the method. We don't really need the array, except that's the only way we can supply all those values, because there's no other way that we know of to create a variable length set of values. And what I mean by that is, I want this method to work if I want to roll 2 n-sided die versus 3 versus 4 versus 5 versus 100, right? I want to support any number of die, but I can't hard code just having one parameter, having 2 parameters, having 3 parameters, having 4 parameters. So a solution to that was to implement an array, which can have any number of values, but then I, from the client side of that method, have to build an array just to call that method. That's kind of a pain, right? That's an overhead that I don't necessarily want in my code inside of my logic. So what I could do as the developer of this method is, instead of using the box notation in my parameter list, I can define this as a variable length parameter where I can do ... So ... effectively allows me to pass in a collection of values into the parameter, and then Java will group them up and automatically house them for me as if it were an array. So now the client code that invokes this method doesn't have to create an array to contain those values. They can just put a comma separated list of values inside that method. So let's see. So I changed the box notation to the ... notation. This only works in parameters. Again, it's called variable length parameter. So instead of having to create this here, I can just take the contents 6, 8, 10, 12. I'll comment this out here because we don't need this die array anymore. And now I can just pass in those values more organically. I want a 6-sided die, an 8-sided die, a 10-sided die, a 12-sided die. Let me go ahead, save that. Let's clear this. Let's compile and let's run it. Notice we get the exact same behavior. And since this is variable length, I can remove one and now have 3 parameters. I can compile, I can run, and you can see now it's going to roll the 3. So this is a very powerful mechanism that effectively reduces the overhead cost on the client to know that they have to create an array, and just allows them to put in the values directly into the method without having to wrap them up themselves. Now, just some words of caution. If you're using a variable length parameter like this, it has to be the last parameter inside of your parameter list, because it's variable length. There's no concept of how long it is. So suppose I needed something like a string in here. I'd have to put the string, say for instance here, in front of the variable length argument. I couldn't put it behind it. Like for instance, I couldn't come back behind here and then put a Boolean value. I don't know. Like this would be illegal because it doesn't know how long this is. So it's just going to assume when it runs out of all the other parameters, that's what the variable length parameter is going to be remaining. So just know that rule. It has to be the very last thing. Here's another question for you. Do you think this is legal? Let me copy this. Do you think I can use the spread operator, the dot operator, the 3 dots, so this spread operator and the box notation simultaneously? Do you think I can overload a method like this? I guess we can always find out. So there we go. We see that we cannot declare both a method that uses the box notation and a method that uses the spread notation, because effectively, internally for Java, they're both represented with arrays. So it uses the same signature. It's just one, the client has to manually build the array, whereas Java automatically builds that array from the collection of values that are passed in. It's effectively like an initializer list that's hidden from the end user. Excellent. Does anyone have any questions about this, or does this seem kind of obvious enough? And one last thing, do you think I can do this? Since we said it's the same thing, before we move on, do you think I could take an int array and then pass it where I would normally have that spread operator? And let's actually get rid of this, where I have this variable length argument defined. Well, the best way to find out is to try to compile, and notice it does go ahead and work. And if we run it, you'll see it works like normal. So the nice thing about the spread operator is that you can still treat it as if it were a parameter that accepts in standard arrays, but if it's a set of values, it'll go ahead and nest those. Again, the deficiency though is that the spread operator, the variable length argument, can only be the last argument inside of your parameter list. So you can only have one. Okay. I guess this is what we had we just did the tester for that. And then we just did this with the spread. Perfect. So we already covered all this. So then the next thing I want to mention in relation to arrays. So we talked about the variable length argument. We've talked about multi-dimensional arrays. We've talked about passing by reference versus passing by values. Let's talk about command line args and the main method. So this will be, I think, let me think about this. We talked about public. We talked about class. We talked about class. We talked about the identifier for class. We talked about curly braces. We talked about public for main. We talked about static for main. We talked about void. We talked about main. That's just a name. String. So this is going to be a string array of args. This is going to be the last of the boilerplate code that we started on the first day of class. So the main method, as you recall, takes in that args parameter inside the main method. Well, we're going to see what that actually does. It allows us to supply command line arguments into our application. So any Java application can accept in any number of arguments from the command line. And so this allows the user to effectively specify typically configuration information into our application before it launches. And the reason why that's what this is usually used for is that you can't use it to get data while the application is running. So you can use it to go ahead and get information before it starts running. So the user enters the command line arguments when invoking an application and specifies them after the name of the class to be run. So for example, suppose we had a Java application that was called sort, which sorts the lines in a file. To sort the data in a file named friends.txt, we might do something like this. We would call on our Java application, we'd give it the Java class that has the main method, let's say it's sort, and then I can put an argument after that when I invoke it from the command line, and that argument will then be put into the args string array when we initially launch, and then we have access to those values. So let's take a look at this. It's pretty relatively easy concept. Let's create a Java application to play around with it. So let's create, what is this called? Command args.java. Take this here. Okay, so quick run through of what we have here. I'm going to create a class, public class command args. Going to end it here. Inside of there, I'm going to just create a main method that has my string array of args. So this is given to me, right? I have access to this args string array inside of my main method because it's in the parameter list. Now, what gets imputed into there is going to be the data that I can, when I first launch this, from my terminal here. So anyway, I'm going to run this without any argument so that we can see what the length of it is initially. So here, since it's an array, keep in mind that arrays track their own length. So we'll print out the length. If the length is greater than 0, then I'm going to do an enhanced for loop on that args, and I'm going to print out the values. Okay, so let's take a look. Let's clear this. Let's compile this code, command args.java. Perfect. Let's just run it like normal, like any other Java application. So I'm just going to do Java command args. Here we see that the length of args is 0, right? Because we haven't supplied any arguments. Okay, so let's do this. Hello. Here now we see the length of args is 1. And since that length is greater than 0, I'm going to do the enhanced for loop on there and then print out the argument inside of args here. Okay, let's do hello world. And so now we could see, we could just separate, we can use a space as a delimiter and put any number of arguments we want after the invocation of our application, after the name of our application, and that'll be placed into that string array of arguments for us. So here we can see the length of args is 2, hello world, and we could do all sorts of things. Like I could do 1, 2, 3. I could put true. I could put 3.14159. Right, and any number of things will then print out. Now, when I do this, what do you think the data type of this of this is? 1, 2, 3. What data type is that when it's inside my Java application? I mean, this should be pretty obvious, right? You're right, it's a string. So keep that in mind, that anything that's coming in from your command line is going to be treated as strings because it's a string array. So if you want to treat that as numerical data, if you want to treat that as Boolean data, you'd have to cast it, right? You can cast it from a string into an integer or into a float or into a Boolean value. But just remember, you would have to do that because otherwise, if I was expecting numbers and I start doing something like this, plus 10, for instance, that's going to be a concatenation operation. One, two, three, 4. Invalid flag. Oh, whoops. Let's actually run it. Yeah, see, we'll just do a concatenation operation. So just be aware of that. The data type here should make it very evident, though. Does anyone have any questions about this? And again, this is this would be maybe an alternate way that we might have implemented homework 4, for instance. So in homework 4, you might have noticed that we use the pipe operator or the redirect operator. I'm sorry, that we use the redirect operator to redirect our system input to look away from the keyboard and instead look at a text file. But I could have done it this way as well. I could have given the text file into our arguments and grab that from the args array and then open it up using the scanner object. The only reason why we didn't do it that way is we hadn't learned about arrays yet for that homework. And and got you a little bit more comfortable working at the command line with some more operators that you hadn't had a chance to see. Excellent. Anyway, that's a really quick concept there. So the last kind of little thing I want to talk about with arrays, just on a general level, since we talked about using command line arguments, we've talked about what the main method is using in terms of the string array and why that's been there all this time to be able to capture command line arguments. Talked a lot about passing by reference and multi-dimensional arrays. Let's talk about exception handling. So there are instances where we might try to do things with arrays that can cause failures, cause our application to not work the way we expect it to. What do you think that might be? How are arrays a little bit more dangerous than, say, for instance, a typical variable? Like with a typical variable, you can read and write to it pretty easily, right? The only difficulty you might have is if you try to use a variable that's out of scope. And then that might lead to an error. And usually that error is can't find symbol, right? And that's because you declared a variable inside a set of curly braces, then you try to access it outside those set of curly braces. With arrays, what do you need to know to be able to access the values from the array? So it's not only the name, like you would a variable, but what's the other piece of data that's super critical? While you think about that, I'll go ahead and start working on building out this other application as a proof of concept. There we go. Well, I'd say the other thing you need to know is what. So if you need a value from an array, there's two things you need, right? The first is the name of the array, but then what's the second? How do you get a value from the array once you know what the array name is? Well, a return statement is definitely what you'd use inside of a method. But let's say that you already have an array and it's already been populated with values. What's required to get one of those values from, let's say you have an array with 10 values, right? And so the array name is a contiguous block of memory that contains all 10 of those values. But at any given time, typically you only want a single value, right? You don't want all 10 at once. Usually you are processing the value at a time. How do you extract an individual value from the array? Exactly, you have an index value, right? The index value represents the individual value you want to grab from that array. But notice that's also a very risky action. Why is that risky? Why could that lead to danger in our software? Why might that lead to failure situations? Why is it not always guaranteed to succeed? What are instances where that might break down for us? If the value of your index, exactly, the value of the index is different than the length of the array. Let's say you try to use an index value that's larger than the length of the array, then that's not actual legal, right? I mean, it's legal, it's an integer, but it's not a valid index number. And so what is Java going to give back in response to that? You don't know, right? Because that you don't have that space and memory reserved. And it's the same thing with a negative number. Technically, a negative number is also an integer, but it's not a proper index number because the topmost element in your array is at index 0. There's no negative indexes inside of Java. So we can potentially get ourselves in trouble because a lot of times when we use the index values, we're doing them programmatically, right? We don't hard code them. We rarely hard code our index values, which means like we do like a for loop. Well, if we accidentally get our index value wrong for whatever reason, then that can lead into failure situations or what we'll call exceptional behaviors in our software. It's exceptional because technically it's legal. Technically, it is legal to give an index value that's outside the bounds of the array, and Java doesn't know that during compile time because it doesn't actually know despite the fact that you declare a size, it doesn't know that you can't do that. It's not checking the size of memory allocated when it goes through the compile step. It's just checking the legality of, is this valid syntax? And so what happens is, this is one of those things that can happen during runtime and not compile time, that produces a lot of erroneous behavior. Okay, let's actually see a piece of code where we might model something and it doesn't work appropriately. So suppose, for instance, that we're going to go ahead and take a student poll on the quality of food on campus, right? Now, for the sake of time, we're just going to imagine that we already have these responses. So the responses, and let me actually do this. The responses are information that we collected with the survey. So suppose that we have, how many people is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that about 15, I guess? So we have about 15 responses here, and we ask students to rank between 1 to 5. What the quality of the food was. So we have like some 1s, some 3s, some 2s, some 5s, some 3s, whatever, right? We want to build software that shows us what is the frequency for each score. So we could do that in a similar way that we did that for our D6 testing, right? So I have these numbers. What I can do is I can create some other array that's called my frequency array, and I'm going to make it the size of 6. Okay, just to make sure everyone understands why I'm doing 6 as the size, what is the concept behind that? And again, I want you to reflect back on what we did for the D6 tester when we were doing that. Why, if the highest score is a 5, why am I going to make an array for my frequency array at size of length 6? Yeah, exactly. So that we have the index value of 5, because what we're going to do, the motivation is we will have a dummy index of 0 that will never be incremented. And then we'll have the actual scores that the students gave as their responses, a 1, a 2, a 3, a 4, and a 5. And so the idea here is that we can create this for loop. So for each score in responses, we can use the score as an index value into the array. So the score itself becomes a part of the model. So our array is modeling the index as the score value. And then we'll call this increment operation. So when we first create an integer array, it defaults, it has to have a default value. So every value in any array has a default value. For integers, it's 0. For floats and doubles, it's 0. For Boolean values, it's false. For strings, it's null. And for all reference types, it's a null reference. That's what that means. I have no reference to anything in memory. So keep that in mind. I think that's actually one of the questions on the next test, is the default values of things inside of arrays. But we'll take advantage of the fact that the default value is 0. So when we first see that score, we'll increment it from 0 to 1. Or if it's 1, it increments to 2. Then what we'll do is we'll go ahead and print out the length of this. I mean, we'll print out the frequency. So I'll do a for loop starting at 1, which is the valid score. I'll go all the way until the length, which is up to 6. So I'll do 1, 2, 3, 4, 5, and then I'll increment. Then what I'll do is in my output statement, I'm going to print the score and then its frequency. Let's see what this looks like when it's working the way we expect it to work. Okay, so here we have the score. So we had 2 1s, 4 2s, 5 3s, 2 4s, and 3 5s. But suppose, and this happens very often, we are dependent on this data that got aggregated for us, that was given to us. Suppose that there was an error when they put that together. Suppose that whoever supplied you with the data forgot this comma right here. how's that going to affect our software? And then here, do I need to blow it up so everyone can see? So what is this last entry now? If I were to, if they just missed that one little, a very easy thing to do, very easy mistake. And again, they're not building the software, so they're just transcribing, whoever's supplying us with this data is just transcribing values. So probably just a mistype on the keyboard. But how's that now going to affect how our software runs? What's going to happen when we get to the value that was 3,5, but is now 35? Yeah, it's outside the scope of 5. And so even though that is a valid, even though that's a legal integer value that can serve as an index place, it's outside the scope of my frequency. So let's see what happens if I try to run it. First of all, let's see if it compiles. It does compile. Let's see what happens when I try to run it. I get an exception, which occurs during runtime, does not occur during compile time. And so these exceptions have names. This particular exception is called an array index out of bound exception. It's located inside of the java.lang package, which means it's part of the standard Java library. We get it without having to import it. And all exceptions include messages so that they can give us information as to what caused our application to effectively crash. So here it says index 35 is outside of the bounds for length 6. And then it even shows me where in my code this happened at. It happened inside the class student poll. It happened inside the main method. In particular, it happened on line 8. And if I go to line 8, it shows me this is the line that is tried to execute when this exception occurred. And of course, that's where we said this is the riskiest time for us to use an array. This is the time that could potentially lead us into a failure condition. Because if we use an index value that is either too large or negative, let's do the same thing with a -5. We'll get that same exception. Index 5 is out of bounds for length 6. Well, if we put a letter, we'll get a different type. So let's say we use a character here. Well, we should get a different type of error. Oh, let me make sure I save that. Oh, let me not use the character. Cars are integers. Let's actually use something that is a different data type. So let's use a string. So here we're going to get a different type of error that's going to say, a string cannot be converted into an int. A car can because it's a key code. And so it'll tell me it's an incompatible type. So if they put just a letter here, let's say they did this though, again, transcription purposes. Let's say they accidentally hit like the A symbol. Well, this is going to be a different type of error it's going to produce. Here it's going to say, cannot find the symbol, because when you don't have the literal symbols around a literal value, whether it's the single quote or the double quote, or whether it's the dot or the period for numerical data, then it's going to think that I'm just referencing some variable here. So yeah, you'll get compile time errors with things like letters, but for things like numbers, like that comma, this is completely hidden because this is a legal value for an integer array. And technically it's a legal value as an index value, just not for our index value. So when we go to run it, then we hit our fail condition. So what can we do in regard to this? That's the question. How can we protect ourselves when we identify that there is a risky thing that might lead to failure in our application? Then there's a way for us to try to address it. Because look what happens when that, again, I want to highlight what happens when that occurs. Okay, let's break it, save that. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, so when this occurs, notice I don't get, it stops my application where that exception occurred and it throws that exception message to me. That means all the processing I did up to that point, I counted all these other frequencies, and up to this point, when I get to here, I crash and I don't get any response, right? I don't get any output, any meaningful output. I get an error to let me know how I can fix this. And how might I fix this, by the way? What might I want to do to fix that? Well, we'll talk about that in just a moment. So what we can do to try to recover from this, because one nice thing about exceptions is they're not exactly like errors. They look on the surface to be like an error that prevents your software from running, but actually it was running. And when it hit that exceptional behavior, that's what caused it to stop running. So when we identify that, hey, there's these instances that could be risky and it might lead us to this exceptional thing happening that's outside of the normal use case, I can create what's called a try catch block. And I can put the exceptional thing inside of the try block. And if it works like normal, then that's fine. But if it doesn't work, then I can try to catch the exception that gets thrown from it. So let's update our code here. So we said this is the part of our code where the exceptional behavior occurs. So I'm going to put that inside of a try. So here I'm going to try to increment the frequency using the score. And on the instance of an array index out of bounds exception, we could see this is what the exception name was inside of my command line. So I'm going to catch an exception by that class name, and then I'm going to give it an identifier so I can access it inside of the catch block. Here, I'm just going to print it out. I'm going to do a system.out.print on the exception object that got thrown. And let me fix this. Let me show you what happens when it's normal, when it's not broken, when we know it's valid and legal, and we should not run into any issues. I'm going to put that comma back between my 3 and my 5. So let's compile that. Let's run this. So here, that ran like normal. So the try catch block doesn't do anything for normally behaving code, but now let's go back and break it. Now we have 35, and we know ahead of time this prevented our code from working. So here we will try to do these things. We know that we will throw a array index out of bounds exception. So that's what this catch block does. We're going to give that exception the label E. Now, what we would do is we would try to figure out, well, if that exception occurs, what do we want to do? How do we fix that? How might we fix this if you encountered this? You might assume that there's supposed to be a comma there, but maybe it was a typo. Maybe that value was really just a 3 and they accidentally like hit the, maybe they were inputting on their phone or something and they accidentally hit the 5. Or maybe it was supposed to be a 5 and they accidentally hit the 3 ahead of time. Because they entered 3 twice. Maybe they double tapped the 3 and then the 5. So maybe it's supposed to be 3, maybe it's supposed to be 5, right? Maybe it's supposed to be 3 and 5. How might we fix that? Like, what are just suggestions? Should we, one way is to put a comma and make the assumption there. Another common thing here is just to delete the erroneous value, right? If we had identified that, but we're not going to do that. We're not going to mutate the actual data set. We're going to leave it as being broken. So we're going to catch this exception. When we catch the exception, we're going to print it out. Now, the nice thing about catching exception is it prevents our system from crashing now. We can recover from it. So where before we didn't get any values back, look what happens now. When we run our code, we're going to print out that exception when it actually occurs. And so when if I print E, notice that is what was happening at the terminal as well. Java.lang.array index out of bounds exception, index 35 out of bounds for length 6. But then where I was normally crashing, because I caught the exception, I was able to finish executing the rest of my application. So we will ignore that. So remember, before, when we had the 3 and the 5, the values of 3 were, it was 2, 4, 5, 2, 3. So if we ignore those last two values, it's going to be 2, 4, 4, 2, 2. So we're able to recover and actually get some kind of meaningful results. And we're going to see this again and again. So this is your first introduction into this concept of being able to identify a risky, dangerous, exceptional thing that might occur in our code, and we can try to defend against it by building this try-catch block. And we'll talk more about how to do that later on throughout the semester. And so this one in particular is the array index out of bounds. Okay, so does anyone have any questions regarding that? Excellent. So the last thing I kind of want to talk about today for the arrays classes, I want to move on from the general basics of arrays. We've pretty much covered everything that's foundationally important about arrays. So at this level, you should have already been well equipped after last lecture to deal with, so last Thursday, to start working on homework 5, because that uses multi-dimensional arrays, and you build kind of like an exploration game of sorts, like a maze game. Now you definitely have all the tools for homework 5. The last part of arrays, we're really going to look at some utility classes for arrays that are given to us that allows us to use arrays in a much more powerful way without having to build tooling for us by ourselves. We have tooling given to us by Java in the java.util class. I want to examine that. I want to look at that. And then I want to follow up by introducing another type of container that uses an array, but it's much more flexible. And that's going to be called an array list. So I'd like to finish today off just talking about the arrays class. The arrays class is a utility class. So it's in the java.util inside the java.util package. So this class contains various methods that we can use to manipulate arrays, such as sorting and searching or filling. We'll talk about those really briefly. Let's see here. And it's technically part of the Java collections framework. So we're going to take a very limited look at the Java collections framework this semester. We're really going to look at the arrays class, which is a utility class, and we're going to look at the array list class. But you're going to go much deeper into the Java collections framework next semester, where you'll look at lists, and you'll look at maps, and you'll look at sets, and you'll look at queues, and you'll look at trees, and you'll look at, I think that's for the most part what you'll cover. Probably hash maps. So just a quick descriptor in terms of the Java collections framework. A collection, sometimes also called a container, is simply just an object that allows you to group multiple elements into a single unit. So you kind of think of an array effectively as a collection or as a container. So collections are used to store, retrieve, manipulate, and aggregate our data together. Typically, they represent a data item in the form of some kind of natural grouping. So it could be like, for instance, a poker hand would be a collection of cards, or a mail folder could be a collection of letters, or a telephone directory would be a collection of phone numbers. And the advantage of using the Java collections framework for these is all the reasons we talked about for the extensibility of the Java programming language. It reduces our programming efforts. It increases the speed by which we can produce our code and the quality. It allows for interoperability between unrelated APIs. It allows us to reduce the effort to design new APIs on our own. And it also fosters software reuse. Let's see here. Let's see. So the catch does remove, I have a question. So the catch does remove to run. Can you program the catch to do something? Yes. So there was a question before I move on too deep into here. There's a question regarding the catch here. Yes, I can program this catch to do any number of things. I could have programmed it to like evaluate the number, for instance, and impute another number there. instead. So, or I could have, well, so when I was asking about strategies, so let me take a step back and just say, when I was asking about strategies, what might we do if we get the wrong number? That's what you would implement inside the catch block. It's whatever your strategy is for handling that exceptional case. And so here, just as a proof of concept, I just printed it out. But more often is the case, you have a tactic on how you want to handle that. And so you would encode your strategy for that inside of the catch block. So yeah, you could do any, you could put any block of code inside of there. In fact, we will see that later on in the semester, how we will recover from a catch. Instead of just printing it out, we'll actually use logic to correct it. Okay, so jumping back over here. So the Java collection framework is going to be something that you're going to see much, much more in Java 2. This is just going to be your first little tasting of it. So there's going to be effectively 3 different categories of operations that it's going to empower us with, right? Processing operations, storage operations, and control operations. Effectively, with arrays, we have a little bit more difficulty doing things like checking whether one array is relational to another array, or if one array is equal to another array, or even be able to cast an array like into a string, for instance. So those are readily obvious to us. They assigning it into arrays is a little bit more difficult than a variable. So like, for instance, we can just write directly into a variable, but for an array, we have to know that index value. Or say, for instance, you want to go ahead and fill your array with just not a default value of 0, but like say the default value of 7 or something. Like there's all these instances that are really useful in terms of how do we store things in the array? How can we process on top of it, such as checking for equality or casting it? Or how do we control things regarding like being able to search for an item or be able to sort all the elements in there? So instead of manually creating that stuff on our own, that's what the utility class for arrays includes for us, all these built-in operations. Okay, so first let's take a look at so I grabbed all this right from the API. Let's look at some very useful classes from array.util. So in fact, what I'm going to do is I'm going to do some live programming here using the J shell. Put this up here. So let me go here. Can I not just create a weird? I want a new one. Oh well. Oh, let's just take this one and move it over here if it wants to be difficult. Okay. And let's see here. Clear that, and let me grab here so we can see this simultaneously. Might be too small. Okay, so for toString method, how we've been able to print the contents of an array up to this point. How have we done that? What was the mechanism by which we printed every element from an array? Easy, that's an easy task, first of all, right? But how did we do it? We would make a method. We pass the array into the method, then we create a for loop and we print each thing into it. So let's go here. There we go. Let's go to, let me launch J shell really quick, which allows me to create. So imagine if I had this array, int, and let's call this array A. We'll start at A. Suppose that I have, let's do a string array. So suppose I have hello, foo, and bar. Okay, so suppose that I have these elements inside of my array. Now, before I would have to create a for loop and print each thing out, but if I import, so let me import from java.util the arrays class. From the arrays class, there is a toString method where I can pass in an array. Remember, I have that array named A. Can everyone see this? Is that big enough? And it's going to create a string for me that's going to look just like so. So instead of me having to implement a simple print method every time I want to examine the state of an array, I can instead just import array, the Java util.arrays, and from there pass the array to this toString method. See, and I get a text representation of it. Let's say I have the same thing here. Let's say that this is a int array. And let's go and do arrays toString for B. I can do the same thing for any type of array. So this is a really practical way for me to be able to display the state of my array at any time as a string. Another popular thing that's really nice to do with arrays is to go ahead and check for equality, right? So what do you think equality should mean for arrays? And let me make another array here. So if I say array A, so I have array B here. Everyone sees array B. It's got the values 1, 2, 3. Okay, so I'm going to make another array. It's called C. And I'm also going to put in there 1, 2, 3. So now let's look at B. Let's look at C. Are these equal? Would you say that those are equal? What do you think I'll get? Oh, what do you think I'll get if I do this? B equal C. False. Why? Yeah, they are separate things. Remember, this is a dangerous thing about the primitive equality operator. The primitive equality operator it checks value to value, primitive value to primitive value. You do not use the primitive operator, equality operator, on reference data types. And these are reference data types. Remember, what it's looking at for reference data types is the memory address. And these are different memory addresses because they're stored in 2 different locations of memory. So if I want to define, so it's all based on how we define equality. What we probably are thinking equality is for arrays is it the same data type? Is it the same length? And does it have the same number of values? That's what the equals method gives me. So if I do arrays dot equals and I pass it B and C, it's going to say it's true now, because that's what we probably think equality is. Whereas A and C, it's going to give me this really exceptional behavior. I guess I should have used the similar data type. Man, how far down does this go? Okay, let's see here. Let's do D. Let's do int array D is equal to. Okay, let's go back up here and do C and D. And then, yeah, and then we'll get false. Okay, let's see here. We saw equals. We have the ability to compare multiple arrays to one another. So this will allow you to see if one array is effectively greater than or equal or the same in size to another array, or the first instance of a mismatch. Let's see what mismatch does, for instance. Here, let's create an array that's E that has the values 1, 2, 6. So I have E and I have B here. So the first instance of a mismatch is at index 2, right? Because they both have 1, they both have 2, but where this is 6, this is 3. So if I go to arrays dot mismatch and I give it both B and E, what's going to happen is it's going to show me index 2 is where there's the first change between the 2 arrays. And if I compare 2 arrays that are the same, was that B and D or was it B and C? I think it was B and C. It's going to give me -1 to say there's no change. So it's an integer value. We talked about sentinel values. This is a sentinel value where any negative value is, hey, these are the same. There's no index when there's an offset. And then let's do like E. Yeah, that was the other one we saw. Excellent. They have the ability where we can copy the contents from one array to the other, and we give the new array a length. So this is examples of not processing operations, but kind of like storing and assignment operations. So suppose that I have this array. Let's say that I have a int array. Let's call this one G. And let's say that I have the values 10, 20, 30, 40, 50. So here I can do arrays dot copy of, I can pass it G, and then I can give it a size that I want. So let's say I want 3 elements. Then it's going to show, it's going to grab the first 3 elements and create a whole new array for me of that size. And notice if I try to do it without defining the size, that's going to lead to an error. Another thing is, suppose that I want an array that's empty filled with a set of default values. I have a fill method. So suppose I had this. Imagine if I had this array that, let's call it, we'll just call it Q, and we will create a new int array of size 10. Okay, so remember, it defaults to being all zeros, but if I go to arrays.fill and I pass it my array and the value I want to fill it, let's say I want to fill it with 7s. Now, when I look at my array, it's going to fill the entire thing with the value of 7s. So again, these aren't difficult things to implement, but they're great quality of life things. The other 2 big ones that I kind of want to leave off is just being able to also sort and search. So here I also have the ability to say, for instance, to arrays.sort, and let's give it a array that is, let's actually create an array that is kind of randomized. So let's create an array Z that has, let's say, 10, 30, 20, 15, 45, and 23. So if I do arrays.sort and I pass it in my Z, and then I examine my Z, notice it's now 10, 20, it's 10, 15, 20, 23, 30, 45. Notice it does mutate the state of my array, right? I'm not doing assignments there. I pass it a reference of my array, and this method goes through and it sorts it for me. And suppose I want to find an element inside that array, then I could also do binary search. Binary search is the argument, it's the type strategy that searching works. So something else you'll learn in the next Java, just know that that's the word we use for searching. So suppose I want to search for the value 20 or 23. I'm going to pass it a reference of my array, and then the value that I want to see if where it is in my array, and it's going to give me the index value. So it's going to say that value 23 is at index 3. So 10, that's 0, 1, 2, 3. Yep, that's at index 3. And if I try to give it something that's not in there, then again, it's going to give me a negative number. Any negative number represents a value that is not inside the array. It's a sentinel value. So we did not find that value. Excellent. Does anyone have any questions about the arrays class? It's a really useful class, right? Lots of cool things that you should know about when you're working with arrays, so you don't have to implement them yourself. What's that? You mean like? Yeah. So I'm now realizing I never did that, but yeah, I could have easily have made a set of negative numbers or a combination of negative positive numbers, and this would be valid, right? So now I have negative numbers in there, and then if I go to arrays.sort and then pass in that X array, it now will sort the negatives in front of the positives. So, I mean, if it's an integer array, any numerical value is technically legal and valid inside of it. And then we'll use the sort mechanism that you probably would expect it to for numerical ordering. Excellent. Does anyone else have any questions? All right, I'll see you all on Thursdays then. Yeah,